Let's compute the following limit by applying L'Hopital rule. Evaluate the following limit. Limit x tends to 0 log of 10x divided by cot x. Limit x tends to 0 log of 10x divided by cot x. We observe that given limit is of the infinity by infinity form. Limit x tends to 0 log of 10x as x approaches 0, tan 0 approaches 0. And so log of tan 0 approaches infinity. So it is of the type infinity by infinity form. So we can differentiate numerator and denominator equal to limit x tends to 0 d dx of the numerator divided by d dx of the denominator. d dx of numerator log of 10x and d dx of denominator is cot x. That's equal to limit x tends to 0 if we differentiate log of cot 10x, we'll get 1 by 10x, and then derivative of 10x is sec square x. If you differentiate cot x, then you will get minus cosec square x. Let's simplify it. We like to simplify it, and so we can write this expression as sec square x divided by 10x into 1 by cosec square x. That's equal to limit x tends to 0 sec square x is one by cos square x, and 1 by cosec square x is sin square x. Sin by cos is tan, and we can cancel 10x and we'll just have minus 10x, and that's equal to 0. Let's do another question. Evaluate limit x tends to pi sin x to the power 10x. Limit x tends to pi sin x to the power 10x. Observe that it is neither of the type 0 by 0 form, nor it is of the type infinity by infinity form. But probably we can reduce it to that. Let y equal to sin x whole thing to the power 10x. Then log y equal to, if we take log both sides, log y equal to 10x into log of sin x. Okay, now we can write this. The right hand side is log of sin x divided by 10 is nothing but 1 by cot. Log of sin x divided by cot x. Now we see that this is of the type infinity by infinity form. When x approaches, is it of infinity by infinity form? As x approaches 0, yes. As x approaches 0, sin x will approach 0 and log of sin x will approach infinity. As x approaches 0, cot x will approach infinity. So, taking limit, if x approaches pi, cot x will also approach infinity here. Taking limit on both sides, we have limit x tends to pi, limit, what we are doing? We are taking limit both sides. We are taking limit both sides. Limit x tends to pi, log y as it is, log of sin x divided by cot x. What did we do? We just took the limit as x approaches pi. Okay, we just took the limit as x approaches pi. Let's take the limit as x approaches pi. This implies limit, we already took the limit as x approaches pi. Limit x approaches pi, log of y equal to let's write everything again. Limit x approaches pi, log of sin x by cot x, log of sin x by cot x, and that is equal to if we apply L'Hopital rule now, log of sin x, if we differentiate, okay, let's write first of all d dx of log of sin x, differentiate the numerator, and d dx of cot x. Limit x tends to pi as it is. Equal to limit x tends to pi, log of sin x, if we differentiate we will get 1 by sin x, derivative of sin x is cos x, derivative of cot x is minus cosec square x. Let's simplify. 1 by cosec square x is sin square x, one by cosec square x is sin square x. So we'll have limit x tends to pi, 1 by cosec square is sin square, so minus sin square x into cos x by sin x. We can cancel sin, and we can cancel sin x and sin x, and observe that as x tends to pi, sin x will tend to 0 and cos x will tend to minus 1, so everything will tend to 0. So what do we have? This implies limit x tends to pi, limit x tends to pi, log of y equal to 0. Now it happens that we can just reverse it, as log is opposite of exponential. We just need to take the exponential here. Limit x tends to pi, y equal to e to the power 0, and e to the power 0 is 1, and your y is function that was given to you, sine x by y is your sine x to the power 10x. Y was sine x to the power 10x. So limit x tends to pi, your y was sine x to the power 10x, and that is equal to 1. Let's do problem on L'Hopital rule. So we have the question, evaluate limit x tends to 0 log of 1 minus x squared divided by log of cos x. We want to evaluate limit x tends to 0 log of 1 minus x squared divided by log of cos x. Answer: we observe that x tends to 0, numerator is tending to log 1, that is 0. Also, as x tends to 0, denominator is tending to again log 1, that is also 0. So the expression is of the form 0 by 0 form. So limit x tends to 0 log of 1 minus x squared divided by log of cos x. First of all, we observe that it is of 0 by 0 form. We can apply L'Hopital rule only in the cases whereby we have 0 by 0 form or infinity by infinity form, or those cases that can be reduced to 0 by 0 form or infinity by infinity form. Now once we have 0 by 0 form, this limit is simply equal to limit x tends to 0 derivative of numerator divided by derivative of denominator. Well, numerator we have log of 1 minus x squared, and denominator we have log of cos x. Let's differentiate it. Log of 1 minus x squared, if we differentiate, we have 1 by 1 minus x squared. We apply chain rule, and derivative of 1 minus x squared is minus 2x. Log of cos x, if we differentiate, you will get 1 by cos x, and derivative cos x is minus sin x. We can cancel minus from numerator and denominator, and then we have this is equal to limit x tends to 0 limit x tends to 0 2x by 1 minus x square into cos x by sin x. Well, we know that we can again apply L'Hopital rule, but it is much easier if we apply the rule limit of product equal to product of limit provided both the limit exist. So this is equal to as x tends to 0, cos 0 is 1. As x tends to 0, 1 minus x squared is also 1. So limit x tends to 0, two cos x by 1 minus x squared into limit x tends to 0, x by sin x. Well, you can apply L'Hopital rule, or you can write it directly. Limit x tends to 0, x by sin x is 1, and limit x tends to 0, cos x by 1 minus x squared is just 2 into 1 by 1. So the limit is 2.